The ID.Fix tool is developed at the University of Iran in the ERISA in real lab. This tool aims at converting automatically in a fixed point a C source code with floating point data types. This tool is developed in the context of source-to-source transformation for high-level synthesis. Commercial tools like Catapult C can be used to design the architecture at the RTL level from a fixed point description of the application. Thus, the goal is to bridge the gap between the floating point description developed by the algorithm designer and the fixed point description used as the input for high-level synthesis tool. During this transformation, the word length for the integer part and the fractional part are determined. Let's have a look at the tool specification. The tool input is the C source code describing the application and in which variables use floating point data types. Pragma are used to express specific behavior and to control the tool. This tool determines the integer and fractional path word length of each data, and the tool generates a new C code in which fixed point data type are used. Currently, AC-fix data type from Mental Graphics are used. The implementation cost is minimized under an accuracy constraint specified by the user. A architecture model is used to know the cost of each operator according to the operand word length. The application converted in this demonstration is part of an OFDM receiver. The C source code is made up of different functions. This application integrates a fast Fourier transform defined through 4 functions describing the butterfly, the stage, and the FFT. Different pragma are used to define the main function at the top of the application, the dynamic range of each input, the output of the application on which the accuracy constraint is applied, and the word length of some variables. The tool has been developed in the GECOS framework. GECOS is a compiler infrastructure able to do source-to-source transformations. GECOS is used as an Eclipse plugin. The different transformations carried out in our tools are defined in a GECOS script. The user has to define the numerical accuracy constraint applied to the output. The quantization noise power is used as the numerical accuracy metric. From the C source code, an intermediate representation is generated from the GECOS frontend. This intermediate representation used for fixed point conversion is a controlled data flow graph. A graphical view of this CDFG can be generated. The originality of our tool is the use of an analytical approach to evaluate the numerical accuracy. This approach is valid for any system made up of smooth operations. The accuracy evaluation module generates a C code describing the analytical expression of the output quantization noise power according to the operand word length. As you can see in the generated file, you can find the expression computed for each noise source, the quantization step Q, the number of eliminated bit K. The gain between the noise source and the output is pre-computed and used in this file. Firstly, the dynamic range is determined with a technique based on interval arithmetic. Then, the data workplace is optimized by minimizing the implementation cost under the numerical accuracy. The architecture model defined with an XML file is loaded. The optimization is carried out with a greedy algorithm. Thanks to the analytical expression of the accuracy metric, the optimization is significantly lower compared to classical approach based on fixed point simulation. Finally, a fixed point C code is regenerated at the output of the tool. For each data contributing to the computation of the output, AC-fix data type are used. This data type defines the total number of bits, the number of bits used for the integer part, the presence of a signed bit, the rounding mode, and the overflow mode. Thanks for watching this short presentation.